A black hole is a sphere called the event horizon. Beyond it, space itself falls into the abyss, and nothing can return from infinity, not even light. But gravity can spread freely from its center. This means that gravity is not connected to space and time and obeys the laws of a universe other than ours. By anomalous gravitational flows of matter, we can judge the impact of parallel worlds, and we can also register gravitational waves from past universes. F equals g multiplied by m1 multiplied by m2 and divided by r squared. This is the law of universal gravitation. Its essence is that the force of attraction between objects is proportional to their mass, and inversely proportional to the square of the distance between them. Newton boldly extrapolated his formula to the entire universe. However, as it turned out, Newton's laws are a special case of the theory of relativity and are very poorly consistent with quantum mechanics. G in the formula of the law of universal gravitation is a dimensionality coefficient, which in this case is the gravitational constant. Fun fact, the smaller the mass of the object scientists used to determine the exact value of G, the greater it was. The fun ended and it turned out that the molecules are attracted to each other more strongly than predicted by Newton's law. During the experiments, it was found that at a distance of 10 to the minus 7th power, the value of G increases by 10 to the 14th power compared to the generally accepted value. This is a graph of the change in the gravitational constant depending on the distance between the interacting objects. Its exponential growth leads to unexpected consequences. At a certain stage, the smaller the mass of the particle, the higher its gravity. If you take a separate isolated particle, its gravity will grow exponentially as the particle decreases, until it reaches the value of the gravity of the entire universe. Then the sign of this gravity will instantly change to the opposite. The particle's antigravity will also decrease exponentially as it decreases further until it reaches zero. In reality, this cannot happen because there are many particles in the same space that influence each other. Take, for example, an isolated particle whose size is so small that its gravity approaches the gravity of the entire universe. And if we add another such particle to it, their combined gravity will drop to almost zero. It looks as if their two fields mutually neutralize each other. In fact, simply doubling the particle's diameter moves the infinitely large value of the gravitational constant from an exponential graph rising vertically to infinity to almost infinity down. In addition, at extremely small distances, the gravitational field no longer decreases inversely proportional to the square of the distance. After all, with increasing distance, the gravitational constant itself quickly decreases. This means that the gravitational field in the nucleus of an atom can have a complex multi-layered structure. Some particles in its composition will have a strong but short-range field. Other particles of a different size will have a weaker but longer-range field. Several such different fields, when added together, will form one field with different layers or waves. In addition, it may contain antigravity layers. The small particles with antigravity that are part of it also create their own antigravity field with their layers. When they are added to the gravitational ones, a common field of different layers is obtained. And it can throw out gravitational bundles or beams. This is when there are gaps between the antigravity fields of individual particles, into which the gravitational field of other particles can emerge. Moreover, this complex field is dynamic. That is, its structure and strength change depending on the mutual movement of the particles. In this case, it can emit gravitational waves. How exactly and what exactly happens in the nuclei of atoms is a task for mathematicians. Something else is important. Scientists try to explain quantum mechanics in the same way as a wild man tries to explain the operation of a smartphone, as simply as possible, but using fabulous forces. If we allow for an exponential growth of the gravitational constant with decreasing size, there is no need to invent mythical nuclear, weak and even electromagnetic interactions. All phenomena are the most common gravity. Electric current in wires is a flow of antigravitationally charged particles with a short-range field. Light and radio waves are gravitational waves of different frequencies and shapes. How, based on this knowledge, can we build a simple anti-gravity screen?